Hi everyone, welcome to Pipesim Python Toolkit for Beginners. In this video, I'm going to demonstrate how to work with table data. Table data are used in many places inside Pipesim model, but I'm going to focus on the flowline profile and well trajectories. As usual, in my code, I import the model class from 6GIL Pipesim and I import everything from 6GIL definitions. Then I specified the path to case study model, which I'm going to use for demonstration, and I decided to save my model in the place where I have access. So I would like to change other different things inside the model and verify it every time using the user interface. So in the next string, you can see that I opened the model and saved it in the temporary folder. Let's check inside the user interface what model we have. So this is the simple model which contains a few flow lines, some equipment, and well. And this is really enough for our demonstration. Let's check the properties of flow line. So flow line configuration, for instance this FL1, has the mode simple, and we see no table data in this flow line. But if we check flow line FL3, for example, we can see that the mode is detailed, and there is table with horizontal distance, measured distance, and elevation. And I'm going to extract this data inside my code. For this purpose, I need to use the method model get geometry. But before I will do it, I need to check that I have access to the model and I can see all flow lines. So first of all, I want to find all flow lines. For this purpose, I use the model find and filter it with model components and flow line. Great, I have access to all flow lines, I can see them, and I'm going to use this FL3 because it has the detailed mode. I will assign FL3 to the variable line, and now I'm going to read the geometry data from the flow line. For this purpose, I will use model get geometry and then specify context and name of the line. So we can see that I received the data set, and it's pandas object with different columns. So we can see the measured distance, horizontal distance, and elevation. And in addition to these three settings, we can see that there is a latitude, longitude, and is vertex option. So these three columns are used when we work with GIS map. But in our example, everything is placed in network schematic, so this value are not used. Let's try to change something. Before I change, I need to assign this output to some variable. I'm going to name this variable geometry and assign results to the geometry. And I need to get access to some value. For instance, I want to change the elevation for 0.1. So instead of 17.5, I will use 20. For this purpose, I need to get access to the column first. So let's use the elevation name. And you can see that I have access to column value. But there is a good practice to use not the name explicitly, but instead of it, use the parameter classes. So for parameters, flow line, I select elevation, and I have the same result, but it's much better. So we have access to geometry, elevation column, and now I need to get access to exactly this value. For this purpose, I'm going to specify the index, and I have access to 70.5, and I'm going to change the value. Instead of 70.5, I'm going to use the 20. So the value was changed, and I would like to check that the data set is changed accordingly. So you see that the value is different, the value is 20. And before we apply this change to the model, I'd like to pay attention that really this data set is wrong, because there is a difference between the columns, measured distance, horizontal distance, and elevation. And if we change one of the value, we need to make sure that the other values are recalculated properly. This is simple geometry, and I'm going to touch it right now, but you need to be aware about it. So it's time to update the value inside the model. For this purpose, I'm going to use similar method, set geometry. And I need to say what context will be used. It will be the same line, and the value I'm going to assign geometry. Let's update the model. So the value was updated, and I need to save the model. Now the model is saved, and I can validate changes from the user interface. Let me just open my model one more time. And you remember that we changed the FL3, and I'm going to open it and check that at the position 2, the elevation was changed, and the value is 20 now. Previously, it was 17.5. And as I already told you, that the original dataset was wrong. Pipesim recalculated measured distance based on horizontal distance and elevation. And this is the reason why you can see the difference in the measured distance in user interface and measured distance in Python toolkit. So, of course, you may do it from the user interface and then update the model, save it one more time. But I recommend you to do everything properly inside the Python toolkit code. Okay, so we successfully extracted the data from the flow line, then changed this data and update it. But what if I want to apply these changes, set the new profile to another one flow line? For instance, I'm going to use the flow line FL4. So you see that this FL4 settings is a simple mode and there is no access to dataset. Let me try first to extract the data from this flow line. For this purpose, I'm going to use FL4 and assign it to the variable line. And I'm going to repeat my code and extract the geometry data from this flow line. You can see that we received error. And this is happened because the flow line FL3 is a simple flow line. So before we get or set any detailed mode and table in this flow line, we need to change the flow line mode. Let's check what variable is responsible for flow line settings. Let's go back and use the line FL1, or we can continue with FL4. But we need to get the list of variables and settings for this flow line. For this purpose, I'm going to use get values, and context will be the line, and we get access to different settings for this variable. I don't really need everything, so first of all, I want to filter and use only the main dictionary. And then I have a lot of different settings and I want to print them all. So let me just assign this to the data. And now I'm going to print values. So for key v in data items, I'm going to print the values. So I will print the key and value. So we have the same output. And if we scroll up, we should find the variable which is responsible for detailed mode, simple or detailed mode. For this purpose, we need to change the variable detailed mode. Let me change it for flow line FL4. So I'm going to set the value context line. Then I'm going to use parameters flow line detailed mode, and the value should be different. Right now we have the false, it's not a detailed mode, but the value should be true. So I changed this value, and let me try to repeat the previous method when I try to extract the geometry. And let me do it one more time. And now we have access to geometry. You see that Python toolkit automatically converted the simple mode to detailed and published all information in the table mode. Now we can work with this dataset. So I want to save the model, make sure from user interface that it was successfully converted to the detailed mode. So let me check flow line for settings. Okay, it was converted. So we see the horizontal distance, measured distance, and elevation. So we can continue with the code. And I'm going to update this model. For this purpose, I'm going to create the special dataset. Let me create the method which returns the dataset. I will create the function create geometry profile. And this function will create the empty dictionary. We call call them survey. Then I need to add something in this dictionary. I will add the first column, parameters, flowline geometry, and measure distance. And I need to assign some value. As we see that the flowline FL4 is a short one, so it's from the distance 0 to 100 feet. So let me increase the size, and I'm going to use the points 0, 100, maybe 500, and 1000. Okay, and I'm going to add another one column, but this column will be called elevation, because I'm going to apply elevation. And the elevation will be simple 0, maybe then 50, 50 again, and 0 again. And we need to return this as a pandas object. So I'm going to return PD data frame survey. But PD is not defined. Before I apply this method, I need to import pandas as a PD. So let's do this. Import pandas as PD. So the pandas was imported. Let me see if I can get this data set. Yes, now I can successfully get the data set. And you see that we have the measured distance and elevation distance. And if I want to apply it, I just need to assign the output to some variable. For instance, it will be called again geometry. And I need to apply, so I'm going to model set geometry. Again, context, line, and value, geometry. And save the model. And now it's time to check what we've done in the user interface. I expect that this dataset will be applied to the flowline. And if we double click on the flowline, you may see that horizontal distance is empty because we provided the data for measured distance and elevation distance. And by default, the measured distance is calculated based on the horizontal, but I did not provide horizontal distance. I want to calculate it. It means that I need to change the way of calculation of this dataset. Let's do it. For this purpose, we need to change the way to calculate. So let's see what the value we have. We have the variable deviation survey calc, and the calculation is a measured distance. I would like to change it, and I would like to use horizontal distance as a calculated variable. So let me set it. Model, set value. Again, I'm going to use context for the same line. Then parameter, and it should be parameters, flow line, and then deviation survey calculation, survey calc. And of course I need to supply the value. The value, we are going to use some constants, so I will use the constants plus, then select deviation survey calculation method, and I have two options: measured distance or horizontal distance. In my case, I'm going to calculate horizontal distance. Let me apply it, save the model, and as usual, check it from user interface. I don't save the model. I go to the flowline settings and see that the horizontal distance was calculated based on my input, measured distance and elevation. So we successfully changed the mode for flowline FL4 from simple to detailed and updated the data. Of course, you can use this way, but again, I recommend you to provide the proper data set when you do the update from Python toolkit and calculate horizontal distance automatically before you update this dataset. But of course, it can be done from the user interface after you updated the model. Everything looks fine except this small chart. You can see that this line is shrinked, but I expect it should be extended. This line shows us ambient temperature. And if we go to the heat transfer tab, you can see another table. So this table defines ambient temperature versus horizontal distance. And horizontal distance was changed by us, but we have not updated this information, so we need to update it as well. Let's go back to the code and extract this value. For access to heat transfer, we need to use the method getGeothermalProfile. So model getGeothermalProfile, and as usual, context. Sorry, this should be context line. And we see the information about this geothermal profile. So the horizontal distance is 100, so I need to update. Let me assign it to geothermal variable, and now I can change the value. So I'm going to change the value for horizontal distance. I can use these parameters, flowline, and then horizontal distance. I have access to column horizontal distance, and I'm going to change the value for 1. And what value should be applied? Because I did not provide the data for horizontal distance, so I'm going to use the data from user interface and copy it here. Okay, so the data is here. There is some warning, but anyway, the geothermal data should be updated. Let's see, yes, the data was updated, and now it's time to update the model. Model set geothermal profile. Again, the context should be line, and the value should be geothermal. The data set is successfully updated inside the model. Save the model and check the changes from user interface. Again, open the model, now save, flowline, and you can see that now everything looks fine. So we updated successfully the table data for flowline and FL4. And the last point I want to show is another way to extract the table from this model. It's the trajectory data for the well. So you may see that we have access to deviation survey for this well. And this is also a table, and we can extract this data. So the well name is well. So I'm going to use this name explicitly. And for extracting the trajectory data, we need to use the method getTrajectory. So let's do it. Model getTrajectory, and then I need to set context. And I'm going to use the name of the well. And voila, we have access to the well trajectory. And following the same idea, we can assign it to variable, change this data set, and apply it back using the set trajectory method.